Okay, so I'd like to welcome you to this introductory webinar on developing fractions sense. This is Dr. Borenson doing the webinar. If we should encounter any technical issues, stay tuned. Usually they are resolved quickly. What I'm doing today is just a small portion of the full day developing fraction sense workshop. So what I'm doing today is maybe 15% of that workshop, probably at a faster rate than we'd be doing at the workshop. At the end of the webinar, we will be raffling the teacher set of developing fraction sense, which consists of the student workbook, instructional hints, and a set of game pieces, fraction blocks. In a national assessment of educational progress, only 49% of 8th graders could place these three fractions in the correct order from smallest to large. So you're talking about 8th graders that have been working with fractions for 3, 4, 5 years, and notice that they have not learned the most basic meaning of what is a fraction. So we really have to always go back to the basics. So let's get started. If the yellow block is a whole, what fractional part is each of the red? You can see that 2 of them fit in the whole. If you ask them, how do we know that each part is a half? Very often the students will say, there are 2 parts that make up the whole. But this answer is not completely correct. Why is that? Because here you have 2 parts that make up the whole, and neither part is a half. So simply saying when parts make up a whole, each part is a half is not mathematically correct. So what we say is that if a whole is partitioned or broken up into 2 equal parts, each part is called a half. Okay, so equal parts, we need a whole, and we need partitioning. And the way we write that is this way. It looks a little algebraic. If y equals 1/2. Using the same reasoning, 3 of the blue blocks form the yellow block. So each one is the yellow block. And so we write, if y is equal to 1, b is equal to 1/3. And likewise, the green block would be equal to 1/6. The children very quickly learn the value of each block based upon the yellow block. They learn that the red is a half, the blue is a third, and the green is a sixth. Okay? Even with very young children, they learn that very quickly. So we need to continue with our basics. We need to know what we mean by a unit fraction. A unit fraction is one part when a whole is partitioned into a. So therefore, each red, blue, or green block is a unit fraction. The blue block is a unit fraction because it's one of 3 equal parts make up a whole. The red unit fraction, and each green block is a unit fraction. A unit fraction is easily recognized because it has a 1 for the numerator. Okay, we need to review the meaning of a fraction. What do we mean by the fraction 3/6? So we mean the quantity by having 3 parts of size 1/6 referring to the same whole. In other words, if you have 1/6 of the Empire State Building, 1/6 of a Kellogg's cornflakes box, and 1/6 of a house, that's not 3/6. They have to be 3/6 of the same whole. And so very often we use the language 3/6 are 3 copies of 1/6, because when you have copies, that forces each part to be the same, that we're talking about the same whole. Okay, so in the webinar and in the workshop, and in the workbook, we use this language of copies. 3/6 are 3 copies of 1/6. And when you get to 10/6, that would be 10 copies of 1/6. So the definition stays the same for all fractions. Okay, so now it's your turn to text, chat, and response. If the yellow block is a whole, this image here represents a fraction. What fraction is represented here? Okay, please text, chat your response. Remember that each red block is a half. What fraction is represented by this? Okay, I see one response. Okay, good. Very nice. 1 1/2 or 3/2. Okay, since we have 3 copies of the half block, we have 3/2. Okay, how about over here, the blue image? What fraction does this represent? The blue image, please. Okay, thirds, very nice. How about the green image? What fraction is represented here? Remember, each green block is a, so this is 5/6. How about here, the red image? What fraction do we have here? Okay, 4/2 or 2. Okay, so the first thing we need to know is that the students are able to recognize the name of fractional representations with the fraction blocks. One other we should touch upon before we get started. 2 fractions are equal or equivalent if they are the same size. So we see here that 2/2 are a whole, 3/3 are a whole, 6/6 is a whole. So the students need to know that for any positive integer n, n over n is 1. 5/5 is a whole, 10/10 is a whole. Okay, that's a critical piece of information that students need to learn as early as the 3rd grade. Okay, so in the 3rd grade program, the students use their fraction blocks to provide the missing number. So let me see if I'm able to do that here for you. Okay, 1 second. Okay, all right, so I don't have it printed out. So oh, but I can do it anyway. Okay, so let's do that. We want to know 1/2 is equal to how many 6ths? So remember, the red block is 1/2. Okay, let's see if we get this focused. The red block is 1/2. We want to know the red block is how many 6ths. So what we would do, that should get more focused. Okay, so what we do then is we figure out how many of the green equal to the red block. Okay, so we see that 1/2 then is equal to 3/6. So the students in the 3rd grade, they do a 3/2, so how many 6 and so on. They do it all using the fraction blocks. Okay, so no rules are presented. They simply figure out how many unit fractions of each you need to equal the other block. In the same way, 1/3 is equal to. Okay, so today's focus is fraction multiplication. So the first thing we need to know is we need to understand the distinction between multiplier and multiplicand. So if we take this simple problem, 2 times is the multiplicand and 2 is the multiplier. So in figuring it out, a multiplication problem, we always begin with the multiplicand. In this case, it's 5. And 2 tells you need 2 sets of them. So 2 times 5 means 2 sets of 5, okay? So we always set up the multiplicand first, and then the multiplier tells you how many sets. The multiplier indicates how many. So in the grade 4 program, the students learned to multiply a fraction a over b by a whole number. So for example, let's say we want to find out the value of 4 times 2. Okay, so let's see how we would do that. Okay, we know that 2/3 are 2 of the blue blocks. So we always begin with the multiplicand. 4 is the multiplier, that means sets of 2/3. Here's a second set of 2/3. Here's a third set of 2/3. And here's a fourth set of 2/3. So notice that the students are able to figure out 4 times 2/3 without you giving them a rule, and they see that the answer is 8/3. Okay, so the students practice that beginning in the 4th grade. 4 times 2/3 are 8/3. We can also show symbolically that 4 times 2/3 are 8/3 because 2/3 means 2/3 added 4 times. And in the 4th grade, we've learned how to add fractions to the common denominator, so the answer is 8/3. So again, in a problem such as 4 times 2/3, the multiplicand is 2/3, and the multiplier is the 4. Okay? Okay, would you please text chat mentally the response to this problem? How much is 3 times 4/5? 3 copies of 4/5. Please text chat your response. What would the answer be? You have 4/5 3 times. What would the answer be? The answer would be 12/5. Okay? 12/5 or 2 2/5. So in general, if you have a fraction a over b multiplied by n, the answer is going to be n times a over b. But notice we do this at the very end. We don't begin with this rule, which is how we were taught when we were in school. We were just given the rule. Okay, next step is we want to multiply a whole number by a unit fraction. 1 over b, as we said earlier, is a unit fraction. So what would be 1/3 of 6? So let's consider we have these 6 chips. 1/3 times 6 means we need to take 1/3 of them. We need to partition these 6 chips into 3 equal parts. And you can see the partition would be here. And so you can see instantly that the answer would be 2. 1/3 of 6 is 2. The part formed by 1 part when the whole is partitioned into 3 equal parts. So the way we did it here is we have 3 boxes and we place these chips one at a time into the boxes. And when we're done, you see that 1/3 of 6 is 2, okay? Now, let's try to understand the difference between 3 times 1/3 and 1/3 times 3. Okay, let's see if we can understand the difference in meaning in these two problems. So, of 3 times 1/3. Okay, question, which is the multiplicand, 3 or 1/3? Please text chat your response. Is the multiplicand 3 or 1/3? It's 1/3. So therefore, we have to begin with 1/3 and take 3 copies of it. So here you have 3 copies of 1/3 make up a whole. This is a visual image of 3 times 1/3 equals 1. Now, 1/3 times 3 means that 3 is the multiplicand. So now you have to begin with 3 wholes. You take 1/3 of them and you get 1. So notice that even though both results are the same, the meanings are different. This is the meaning of 3 times 1/3, and this is the meaning of 1/3 times 3. Would you text chat good if you follow? Text chat good. Okay, also, hopefully we will have a recording of this for you to review or share. Okay, next step. Now we want to find out how we multiply a whole number by a non-unit fraction. A is 2, 3, 4, 5. It's not 1. So let's take 5/3 of 6. So let's look at that for a second. We already know that 1/3 of 6 is 2. And we know the 5/3 are 5 copies of a third. So 5/3 of 6 is going to be what? Text chat the answer if 5/3 of 6 would be 5 copies of a third of 6. Okay, good. We define 5/3 times 6 to be the size of 5 copies of a third of 6. We already know that a third of 6 is 2 blocks. So 5/3 of it means we have to take this box and duplicate it 5 times. And if you do that, you see that you have 10 chips. So 5/3 of 6 is 10. So in order to take 5/3 of 6, we first found 1/3 of 6 and took 5 copies of it. Now you can express that symbolically this way. 5/3 times 6 equals 5 times 1/3 of 6. We know that this is 2 and we get 10. Okay, would you please let me know what is the missing number? 3/4 times 20 is the same thing as a whole number times 1/4 of 20. What's the first box? What's the second box? And what's the third box? Okay, so 3/4 times 20 is the same thing as 3 copies of 1/4 of 20, and the same thing for all of them, okay? So 5/2 of 12 are 5 copies of 1/2 of 12. Would you please calculate this mentally and write down the text chat your response? 5/4 of 12 is... Okay, so first we need to figure out 1/4 of 12. We know that's going to be 3. We need 5 copies of that, so the answer will be 15. Okay, 5/4 of 12 are 5 copies of 1/4 of 12, so the answer is 15. Okay, now we want to know how to calculate a unit fraction of a fraction. So let's consider 1/2 times 4/3. Okay, so let me see if I can illustrate that here. Okay. Notice again, we don't give the students any rules to begin with. They simply do the okay. Which is the multiplicand, 1/2 or 4/3? The multiplicand is 4/3, okay? So therefore, in order to do this problem, we have to begin with 4/3. Now, the multiplier tells you what you do with those. It says to take half of these. So this would be half. You don't have to arrange it that way. And this would be half. So half of 4/3 is going to be 2/3. Okay, so if you have 4/3, half of that will be 2/3. 4/3 is 2/3. We can also see that half of 4/3, you're writing 4/3 as 2/3 plus 2/3. So therefore, half of 4/3 is 2. I gave this name symbolic partition of 4/3. Okay. Okay, please answer these questions. How much is half of 12/3? Your response, please. Half of 12/3. Good. Half of 20/4. Half of 20/4 would be 10/4. How about half of 8/5? half of 8/5 would be 4/5. Okay? So to take half of a fraction, we simply take half of the numerator and keep the denominator. Just like half of 8 apples are 4 apples, half of 8/5 would be 4/5. Now let's look at this problem. You're told that the value of the yellow block is 12/19. We need to figure out the value of each blue block. Would you think about 10 seconds and text chat your response? What is the blue block here? Notice you have 3 blue blocks that make up the yellow block, which is 12/19. What is the blue? Okay, I'm getting one answer from Ann of 4/19. So let's look at that. If this is 4/19, and this is 4/19, and this is 19, I think you will have 19. So the problem really says, what's a third of 12/19? And it's going to be 4/19. Okay, would you all text chat okay if you see that a of 12/19 is 4/19? Do you all see that? Text chat okay? A third of, it's good. So to take a third of a fraction, we simply take a third of the numerator and keep the denominator. A third of 9/10 is 3/10. Okay, let's see how we do with these. What's a third of 6/5? Your response, please. A third of 6/5. 1/3 of 6/5 are 2/5. What's a fourth of 12/7? A fourth of 12/7 would be 3/7. Good. Great. What's a fifth of 25/4? 5/4. Okay, good. Excellent. Excellent. Good. So in general, for fraction, we simply take 1/n of the numerator and keep the denominator. So now we're ready for what we're really after. How do we a fraction by a fraction? So let's look at 5/3 times 3/6. What needs to be partitioned here? What is your answer to that? Is it the 5/3 or the 3/6 which needs to be partitioned? What always needs to be partitioned is the multiplicand, right? We begin with the multiplicand, and that would be 3/6. Into how many parts do we need to partition the 3/6? In order to get 5/3, into how many parts do we need to partition the 3/6? Okay, that's maybe a difficult question. The answer is 3 parts. How many copies do you need? You will need 5 parts. Okay, so let's actually do that. Okay, let's see how that works. Okay, here we go. 5/3 times 3/6. Okay, so we need to begin with 3/6. Now, I need to take 5/3 of this, but before I can take 5/3, I need to take 1/3. 1/3 of 3/6 is one of those. So this is 1/3, and now 5/3 means I need 5 copies of that. 1, 2, 3, 4, 5. So the answer should be 5/6. 5/3 of 3/6 should be 5/6. I'm going to do that again for you. We begin with 3/6. In order to get 5/3 of 3/6, first we need to get 1/3 of 3/6. This is 1/3. And I can take 5 copies of it. And the answer would be 5/6. So let's see it over here. 1/3 of 3/6 is 1 green block. So 5/3 would be 5 copies of those, or 5/6. How many of you think you see that? Text chat, yes? You think you see that? Okay, so here I have a video of an 8-year-old third grader. She's doing 2/3 of 9/6. Now, you won't be able to hear her, but you'll be able to see her, and I'll just be telling you what she says. Okay, so let's try this out. I want you to help me with this problem. We need to find 2/3 of 9/6. Which is the multiplicand? So we need to begin with 9/6. Would you please place 9/6 on this paper? So she's placing down the multiplicand first, which is 9/6. Good. In order to find 2/3 of 9/6, we need to partition the 9/6 into 3 equal parts. She's trying to separate the 9/6 into 3 equal parts. Okay, finally she's getting it. Show me 1/3 of 9/6. That's 1/3 of 9/6. Show me 2/3 of 9/6. That is 2/3 of 9/6. So how much do you have the altogether? A whole, she says, equal to a whole. And she's going to write the answer equals 1. 1/3 of 9/6 is equal to 1. Third grade. We have more than page, by the way, Borenson Math. This is one of them. So this is how she's doing this problem. Okay. Wow, this one looks interesting. I'm going to need your help here. We need to figure out 3/5 of. Now you're saying, how do we work with fifths when we have fraction blocks? So I need your help. What should I start with in order to 3/5 of 2.5? What should I start with? Okay, so Anne is telling me to begin with 2.5. Okay, I'm going to do that. 1, 2.5. Now, we need to take 3/5 of this. How are we going to take 3/5 of all of this? I need your suggestions. I have to break all this up into 5 equal parts. Okay, a suggestion is being made to make an exchange. Exchange the yellow blocks for red blocks. So let's try that. So notice we still have 2.5, but now we are in a position to take 3/5 of all of that because each of these red blocks is 1/5. So therefore, what will the answer be? What will the answer be? 3/5 of 2.5 is what? Text out your response. This is 1/5, 2/5, 3/5. So the answer looks like it's going to be 1.5. Okay, it looks like the answer is going to be 1.5. All right. So 3/5 of 2.5, we first rename it that way, and then that would be 1/5 of 2.5, and this would be 3/5. So the answer is 1.5. Okay, we previously saw a video of a young student using 9 green blocks to find the product 2/3 times 9/6. Let's now show a different approach, the symbolic partition approach. We're going to partition 9/6 in. Can you text chat for me? What will each part look like if you partition 9 into 3 equal parts? What's the value of each part? If you partition 9/6 into 3 equal parts, each part is 3/6 because plus 3/6 is 9/6. And now, to take 2/3 of 9/6, we take 2 of those parts. And so the answer would be 6/6 or a whole. Okay, so 2/3 of 9/6 a whole. So this is what I'm calling the symbolic Tician approach. Okay, I need to find out 3/4 of 8/5. So I need to partition 8/5 into a certain number of equal parts. How many equal parts do I need to partition it into? To take 3 8/5, I need to first partition the 8/5 into okay, the symbolic partition approach, we need to partition 8/5 into 4 equal parts because we need to find 3/4. How do we partition 8/5 into 4 equal parts? You do it this way. 8/5 is equal to 2/5 plus 2/5 plus 2/5. And now we see that 1/4 of 8/5 is 2/5. That's 1. And we see that 3/4 6/5. Okay, so if this is a little fast for you, you'll have the video. But essentially what you're doing is you're verifying that 3/4 of 8/5 are 3 of 8/5 because 8/5 can be written as 2/5 4 times. If you think you're okay, please text chat. Think okay. If you think you're okay with this, please text chat. You will have the video though, hopefully. Okay, let's calculate mentally. Calculate mentally. What is 5/3 of 12/7? Are you able to do all of this mentally? Well, 7. Let's see. 1/3 of 12/7 is 4/7 times 5 is 20. So 27 looks good. Okay. Let's now show a solution using a rectangular grid. We need 2/3 of 4/5. So when we use a rectangular grid, we look at the denominators 3 and 5, and that tells us we need a 3x5 grid. Okay. We use 3x5 grid because the denominators are 3 and 5. Now we know that 4/5 is a multiplicand. So that means the first thing we need to, well anyway, before I get to there, this 3x5 grid has 15 boxes. Each small box is 1/15. Okay, 3, 6. Since the multiplicand is 4/5, we now shade 4/5 of the grid. 1/5, 2/5, 3/5, 4/5. And now we need to take 2/3 of that. So notice that you have a third here, a third here, a third here. So 2/3 of the 4/5 gives you this double shaded portion. Now, what is the value of the double shaded? We said before that each small box is a 5th. 2, 4, 6, 8. So 2/3 of 4/5 is 8/15. Let's calculate 2/3 times 4/5 using arithmetic. Now, notice that we cannot easily take 1/3 of 4 is not a multiple of 3. So in order to make the 4/5 a multiple of 3, what I'm going to do is 4/5, so I'm multiplying numerator and denominator by 3, and I get 12/15. Those are equivalent fractions. So therefore, 2/3 times 4/5 will be the same as 2/3 times 12/15. Do you agree with that? That 2/3 of 4/5 is the 2/3 of 12/15. Do you agree? Okay, since both of these are the same, this answer should be the same as that answer. And now notice that now we can easily figure this out, because a third of 12/15 is 4/15 times 2 is 8/15. So again, when we're not able to take a third of 4/5, we can always multiply the numerator and denominator by 3 in this case. And then you'll have a fraction that will enable you to take a third. Let's try another. Oh, this is also a third. I should wait up. Oh, that's the same problem. Oh, this is a new one. Okay, good. Let's take 2/5 of 3/4. You cannot take a fifth of 3/4. So let's change 3/4 to 15/20 by multiplying the 3 and the 4 by 5. So now we can take 2/5 of 15/20. A fifth of 3/20 times 2 is 6/20. Now notice that we got 8/15 can be obtained by simply multiplying the numerators and denominators of the given fraction. Likewise here, 6/20 that we got is the same. So therefore, we can now generalize and state the general rule that in multiplying two fractions, you can multiply the numerators, the denominators, and divide one by the other. Very often, though, this is all we tell our students. We leave out everything that came before here. Okay, I need your help here. I need your help. First example, what is 3/5 of 5/11? You may use this formula. What is 3/5 of 7/11, please? Okay, I'm seeing 21/55. 3 times 7 is 21. 5 times 11 is 55. Look at the second one. What is, mentally, what is 5/37 of 74/92? Notice that for the second example, if you have to multiply 37 by 92, that's a lot of work. 5 times 74. So Anne, how did you get 90 seconds, please? So I think what you did is you took a 37th of 74, which is 2. You took 1. I simplified 37 and 74. Okay, so you're using, it seems like you're using an approach we learned in high school. I'm not sure we're using this same exact approach. So the way we're presenting it here is you can take 1/37 of 74/92, which is 2 90-seconds, and you multiply by 5 and you get 10 90-seconds, which is 5/46. Okay, you can also apply this to word problems. After grading the final algebra exam, Mrs. Green noticed 3/4 of the students passed the exam. Of those who passed, 1/5 received of 8. Do you know whether 3/4 is the multiplicand or 1/5? 3/4 passed the exam, and of those, 1/5 received a grade of A. So it looks like we need to know 3/4 first. Write an equation to represent the problem, solve the equation. So I'll just show you here because of time limitations. Let A be the fraction of students in the class who received an A. So it's going to be 1/5 of 3/4. 3/4 is the multiplicand. Those are the kids who passed the exam, and 1/5 received an A, so the answer is 320. Okay, so I want to thank you for your participation in this webinar. Implement the program. Each student has a student workbook, a set of fraction blocks, and a white bowl to hold the pieces. We have a full-day workshop. We only covered about 15% of the 5th grade material. So we've shared instructional strategies which enable students to make sense of fractions. So before we do the raffle, can I get some feedback from you? Okay, give me some feedback. What are your thoughts about what we did here today? Okay, let me hear from a couple of you. Okay, I just want to hear a few comments. Anything you particularly liked? What did you enjoy? Okay, good, wonderful. Okay, very good. Okay, great, thank you. Okay, so we had 15 people signed up for the webinar. Not all of them came on. I think we have 7 altogether, more or less. Anyway, so what I need you to do now is please enter a number between 1 and 15. Enter a number between 1 and 15. So we could see who wins this set, okay? Okay, so anybody else? Okay, let me just see if there's anybody else here. Lena, are you with us? Can you enter a number between 1 and 15? Okay, so I think we have a raffle winner. Let's see who the winner is. Let's reveal her. The winner is, the number is 15. It looks like Anne is the winner. Okay, Anne, congratulations. My office will be in touch with you, but you can also contact us, info@borenson.com. So I want to thank you all for participating in this webinar. It looks like like we did not have the internet trouble I was expecting, and the recording should work. So, down. Does anyone have a question? Okay, so thank you so much. Have a great day.